Hi everyone, thanks for coming today to this month's webinar. Today we're going to talk about the aspects of code in a microservice, and I speak a lot about clean code and stuff like that, stability. We're going to have aspects of that today, and but that would be in the context of microservices, because I think apart from that's a lot of the architecture that the buzz architecture today, which makes a lot of sense. It comes along with some things that are very important, I think, to apply in terms of patterns. And usually when we talk about clean code, we talk about patterns of clean code with naming, extraction, stuff like that, but not just in the context of making things clearer, but here I think applying design patterns inside the code can help us as well, and we'll see how. I'm your host, Gil Zilberfeld. I'm a consultant and a trainer and mentor, and I talk about a lot of stuff, and I'm testing, unit testing, clean code, and other stuff as well, microservices as well. And I'm the author of 2 books, Everyday Unit Testing, Everyday Spring Testing. You can get in touch with me at gil@testingguild.com. Go to the testingguild.com or everydayunittesting.com, same site. Redirection is wonderful. And you can get in touch with me on Twitter while Elon allows it. So if you have any questions, please put them in the Q&A box. I'll try to get them as I can. If not possible, I'll do that at the end. I want to start like I mostly do at the end. This is the goal. This is what we want. Code that works, which basically depends on your definition of what works. And we want that to be done over and over again. So we implement things incrementally, we build stuff incrementally. So we want that to work incrementally. We don't want to lose quality. And one of the things that I always mention around the different practices that we do in order to maintain that and maintain some kind of delivery speed, velocity, how you want to call it, is that we want to do that and not slow down. So we need to do all kinds of things to do that. And the problem is that if we have like something like a spaghetti code, or we build something that turns out into spaghetti, or whatever kind of pasta that you like or don't like, it kind of bogs us down. The thing is that code is becoming hard to change and hard to test. And these are the 2 things that we want. Things are going to change. We're going to need them to actually change the code. And the other thing is that want to make it work. So we need to test it. In a microservice world, it becomes, I won't say easier or simpler, but the starting point is simpler because a microservice is smaller. It's more contained. If things are already not part of our code, it would probably be another service. So the thinking about like dividing stuff and separating stuff into smaller things and more cohesive things is already there. So at the end, it's up to us. We're gonna either refactor the code or like use it as a legacy for somebody else. Today, we're going to choose number 1. What we want. So basically, we can do a lot of things with the code, and there are kind of principles that guide us in order to do that. And in order to able to change the code or modify it like without risks, we need to test it, obviously. But the way we kind of guide ourselves through the refactoring would be to things that we're always there in terms of software design, cohesion and separation concerns. I'll talk about them in a second. In order to easily tested because everything's testable, just a matter of time, effort, and how much you put your soul into this. First of all, reduce dependencies, which is a good start to have in microservice because kind of limit ourselves, kind of lock ourselves into what we're doing, the bounded context in domain-driven speak, and the rest could be like through APIs and stuff like that. So we want to reduce dependencies, and we want to have loosely coupled interfaces and events because that will help us test and maybe replace stuff with mocks and stuff like that. Apart from reduced dependencies, which kind of means what it means, cohesion is the degree of which elements inside a module belong together. It's basically code that goes together and changes together. Makes sense that it stays together in one place. Now, what is one place? If we're talking about level of code, not the level of diagram or modules, we're actually saying, well, in this kind of microservice, I'm going to show this in a Java project, a Spring project. So it's inside a project, we're talking about classes and things that go together within classes or same packages. If they're not, they should be separated. This is the Dr. Jekyll to the Mr. Hyde stuff. Separation of concerns. If each module addresses a separate concern, then separate these things. Pull them apart, not in the same class, maybe not in the same package, maybe not in the same service. So it's really like these kind of principles go along. And if they're working, we know it, but there's a lot of gray area between them that we need to apply some thought and think about what actually goes together. But if we are able to actually do the separation, it will help us, and I'll show at the end what it helps us with. Loose coupling is, the definition is that components talk to each other without knowing how the other is implemented. So it could be like at the code level, talking to interfaces, abstract classes, or sending messages without publishing messages without knowing who will catch it and do something with it. So these are examples of loose coupling. The more we can do that, we can again separate stuff and not rely on the implementation, allows us to work against the interface and maybe mock the dependencies or do something else with it. So these are the principles. I want to add another one though. This is not the design. This is more productivity things. So if I was like writing everything from scratch, I would probably do these things, but I would probably work for a lot of time. Today, nobody writes things from scratch, right? So I'm going to be using Spring as my engine and framework of writing the APIs, and it could be whatever you're using, maybe using whatever language you use. We have a lot of frameworks to use to build stuff, and we want to do that. So we want to use things, and that ties up, it couples us to these kind of frameworks, because if I'm using Spring, it's going to be like things that are auto-wired, because this is a lot of the things that Spring is famous for, started as a dependency injection framework, allows us to inject things wherever we want, but it couples the code to that, and it impacts our ability to push code around, like we'll see, and maybe test. So I want to use the tools, but I want to use that smartly so they will not affect what I want to achieve. So here's the plan. I'm going to start with a code that works, but a bit messy. Hey, let's face it, it's going to be a lot messy. And I'm going to separate concerns, like start moving code around based off what I think makes sense in terms of responsibilities. I'm going to talk about that. And we're going to refactor the patterns. So the way we're going to move the code around is based on different design patterns. I'm going to talk about them, and I'm going to show them in the code. Finally, we're going to have the code itself, which is going to be in a much better place. We could talk about this as well, because we're gonna get some capabilities out of that organization. Want to mention, so this is material here is part of my course about introduction to microservices, because a lot of the things that I'm talking about is not just what microservices are, but also how they are they should be written. And this also the code level, and maybe there's going to be a separate I have an idea for testable microservices, which this thing is going to be part of it as well. If you're interested, ping me, let me know. So what we're going to do. So the microservice that we're going to look at is a scheduling, meeting scheduling service. Has one API, needs to fit the context, right? But it does have some things in it. Basically, one API, you're doing a post, I'll show you that in a minute, and you schedule a meeting. There are going to be a few entities that we're going to use. There's the calendar, which basically contains a bunch of meetings. There are the meetings themselves that have an ID, a time and date, a room, a name, a topic, something like that, and a meeting as invitees. Both calendar and invitees, you see the invitees have an ID, email, and invitation status, like sent, not sent, confirmed, and so on. You also see that the meeting status as well, we have meeting created, scheduled, and so on. The calendar and the invitee stuff are basic data, just data. And the meeting and the invitees are going to be saved in the database. But the meeting has some behavior in it because it kind of changes state. So we have a schedule thing that schedules the meeting, basically saves it in the database. Invite participants, what we don't see here, actually sends a message outside. So per invitee, I'm going to use Kafka as the messaging broker, but basically these are the things that are the meat of our service. The architecture, and like I said, I'm going to use Spring. So I'm going to use a REST controller, an API, a REST API, calling the meeting logic, which calls data access layer. Is going to use Spring repositories for the data, JPA, and a database. I'm going to use H2. Obviously, this will work with anything, but I'll talk about that too. So this is the API. It's a post, meeting schedule. I'm going to send a body, and this is a JSON example of what I'm sending. Emails, like the invitees emails, with the date and time, which is a local date time representation, the meeting topic, and the room ID. That's basically what it does from the outside. A couple of things about it. It's a mess. You'll see in a minute. If you think about it, I gave you a single API. And I told you, well, it actually saves data in the database and sends messages out. How can you check that? Well, that's a problem, because if we were talking about black box, I won't be able to look at the data. So all the tests that we're going to do, because I didn't give you an API to retrieve data, that's a problem. So all the tests in order to prove that things can be done are already sort of a white box tests, which is okay. And we're going to look in the database in order to find information and so on. We can check a couple of things, but in order for that, we're going to go into the code. So we're starting here. So I'm going to start at the controller. You'll see numbers 1, 2, 3, 4, and up until 6. That's because Spring doesn't like same bean names and routes and stuff like that. So if the number applies to the package or the step in our way, ignore that. So what do we have as a controller? So controller basically has, we're going to meetings 1 or meetings, 2 repositories. These are the Spring repositories, the JCrud repositories. So one for the meeting, one for the invitees. Basically, we're creating a calendar. The calendar doesn't do anything but store the repository. And now we have some kind of validation. We'll talk about that before we create the meeting. But if everything is valid, then calendar creates the meeting and calls invite the participants on the meeting itself and returns meeting created, or if it's not valid, returns a bad request. Okay, so that's okay. Let's look at the meeting because the meeting is the more important stuff. Oh, I haven't showed you the meeting request that we are getting. This is what we get from the outside, the body of the message. This is basically it. Let's look at the meeting. So I'm using JPA entities. The meeting is here, holds the CRUDs, are already not auto-wired the repositories directly to the meeting. This is something that I want to get rid of because my goal at the end would be like meeting and invitees, whatever we consider part of the domain, we want it pure. We don't want it as few dependencies as we can. So we have some of this we can't get rid of, and that is like the ORM stuff. So we have the tables and IDs and stuff like that. Data, blah, blah, blah. And now, since the meeting sends the invitation for the thing, it has a Kafka producer, sets it up in the constructor, all the properties. You already understand that we're going to move this away because we don't want it here. But the examples I created is a bit messy because I've seen these kind of things. So the constructor just basically passes things on, fills up the data. The schedule method changes the status to schedule because it's created with created, and then saves the data into the database, and then invites participants, basically goes over each invitee and sends out an invite message, which is kind of a record here, just data. So it's going down into JSON, and this is what we send out. Basically, that's it. So this is most of what we're trying to do. You've seen the code, but as you've seen, it is a bit messy. So where is my thing? The first thing that we're going to do is organize. I'm not going even to touch it. Code organization, just like moving stuff around, is also refactoring. We're changing the form without changing the functionality. Oh, I haven't showed you yet. I told you that I already have some kind of tests here. So let's look at the test that we have at the beginning. The first test I have are data tests or Spring data tests. This actually allow us to create the object and save them and look if they we can retrieve them. So we have like meeting stuff and the invitee stuff. We can check that they are loaded correctly into the database, they're retrieved correctly. So create meeting with no invitees. These are basically creating the meetings with a meeting request, get parsed, persisted, see if they actually work, and meeting with two invitees and so on, check if we can retrieve them. So that's one part. The other test that we can have is an end-to-end test. Now, this is a bit of a bigger one. Like I said, we need a white box. We need to log into the database to see the data is stored there. And we need to make sure that when we're sending a message, we're getting the message someone else. So we can do this in different ways. I decided for the simplicity and in the real world to use as much as possible a contained system, isolated system. Spring allows me to both call the APIs, have the database and an embedded Kafka in process. So that means if something fails, I'll know where in the code it is. Same kind of test I can actually do within test containers or deploy it in different packages and call the APIs from there. What happens in this test? So I'm using mock MVC to do the internal calls. One one test is when scheduling a meeting in the database. I want to see the database is updated and invitation sent. So basically do the perform API, calling the API itself, and then using the repository thing to validate the invitation is sent, like the status is sent in the database, and validate meeting name and scheduled status in there. And then I'm going to use a Kafka consumer to listen that I get the message. So this is like an end-to-end thing. Another test that I have, that creating an invalid, sending invalid meeting data, the meeting is not created and no invitation is sent, like a timeout. Okay, so these are two things. It's okay, but a lot of things can go wrong here, because this is like an end-to-end test and nothing is mocked here really, but I'm calling everything inside the process. And like I said, this can be also in a configuration where everything is deployed, everything is different. They have their own pod or something, and I'm calling the API and I'm expecting these things to return. Like I said, the first thing that I'm going to do is organize these things. So I'm going to close down the tests. Just look at these things. Everything's piled up in one package. Let's organize this a bit. So same code goes here. I gave a package to the controller itself, put in the data things, the two repositories and the invite message, the record that I'm sending. And everything else goes into the domain. The calendar, the invitee and the meeting, and the meeting request status and the enum stuff. So that's the first thing. It already looks better. Helped me when I was creating this thing, because I created a mess. I needed to do some kind of organization. So that's cool. We've organized stuff. We went to the code. And now let's do something. Let's actually change the code. So how are we going to do this? So we talked about principles of separation. There's another architecture model, call it. And this one's been out there from, I think, from the 80s. So it's not a new thing. It's called ports and adapters. And another name that you may find is hexagonal architecture. This is like the shape. And it was introduced by Alistair Coburn, like I said, back in the 80s. And what he says is basically like something like this. We have like the application core, like the entities and the behavior of our domain. This is something that may require talking to other stuff. We already have seen what this other stuff is. Exposing APIs, we're exposing it to the clients. Talking to the database, we've seen the repositories that Spring allows us to use. So everything else, and Kafka or something like that. So we already seen that when the code is jumbled together, it's hard to read, hard to change, hard to maintain. So the idea is this: the application, what we call the core, stays pure, and we talk to other things through adapters. So we kind of start pushing code outside. You already have adapters, like I said, built in. The controller is an adapter. The repositories are adapters, but we're going to have more of this. So this would be like the main thing. The goal would be to have a cool, pure, clean domain, and we'll see how to get there. The first thing that we're going to move is through an idea called anti-corruption layer. It comes from domain-driven design. And basically it says that adapters that insulate bounded context and enforce correct, consistent translation. What does that mean? Remember the validation that I showed you? And then I'll show you exactly what it means. What happens if we pass invalid data into our code? So let's see what the rules are for our message. So if we want to create a meeting, it has to have a topic, has to have at least one invitee, and it has to be in the future. This is the code that already exists in the controller, and we're going to move that to a separate object. First of all, why do we need that? Well, let's assume that we can allow invalid meetings to be created. Let's take the topic one, for example. So let's say that we have, we allow creating a meeting without a topic. Now, in terms of our domain, in terms of code, but first of all, so what? in terms of a domain, how do you search for meetings without topics? So we need to now write extra code for what happens when you search for a meeting with another topic, or what happens if you don't have an invitee? How do you send the invitation out? So you have to write custom code for the cases where we don't have any invitees. If we allow invalid stuff into our domain, we need to take care of the special cases. So if we want to make it more simple, less complex, we need to not corrupt our domain. And this is what the anti-corruption layer says. And basically what we need is already there. It's the validation of this kind of code, the valid of the request before we create a meeting. It's already there in the controller. But first of all, we're going to separate that into its own thing. So let's jump into the code and see. So our controller has this code here. So basically it checks that the validity, if we don't have invitees, or it's in the past, or the topic is empty, it's going to be invalid. So in the next step, the anti-corruption step, I'm going to have an anti-corruption package, put a meeting validator here, and do some refactoring to make it more readable. So whatever, no participants in the past topic means it's false, otherwise it's true. The controller obviously creates this and use it. Why is that good? I can unit test that, but we'll keep that to the end. See, this has no dependencies whatsoever, just looks at the translation of a meeting request, and it basically tells you if it's valid or not. Okay, I know, some improvement, but not a big one. Let's go back to our fighting champion. So next thing that we're going to talk about are repositories. Right? So a repository is a design pattern that basically, well, I'll read what it says: mechanism for encapsulating storage, retrieval, and search behavior, which emulates collection of objects. Basically, it separates the use of an entity from its persistence. So potentially, I can keep my entity ignorant of how it's going to be saved or loaded, and I can save it in a relational database, in a file or key value, whatever you want, and the entity doesn't change. Now, it's true that Springs gives us a repository, just builds something for us, and that's okay. It's cool. Like I said, we want to use the tools that we have. And but it comes with a price. There are basically two things. First, it has to be injected. Like, it doesn't load up from nothing. It has to be run on a Spring platform. And so that means it's a bit heavy, and sometimes I want to just mock the interface, but this is okay. But I still need to load these things up. Second thing is that it doesn't speak the same. It has a generic interface. It doesn't speak the language of the domain. So I may want to move things around. So let's go back to the code. Okay, so let's look again at what we have. Our controller is auto-wiring the repositories and passes them into the meeting repository, so which is okay. Let's look just at the definition of the CRUD meeting repository. Doesn't do anything. It just implements the CRUD repository interface, extends it, and when Spring loads up, it identifies it, say, we have a cool Hibernate and repository here. Let's create one for you and inject it, which is okay. It's not a bad thing. But in the meeting itself, when we're doing this, so find all, it's nice, but yeah, we can do something else. So two things happen in the meeting. First of all, where is it? When the meeting is scheduled and when invite participant happens. Oh, bug here. I need to call update all, which saves the data to the repository and invites everyone. Excellent. But it's still a repository. We need to save, find all, do stuff like that. Let's create our own repository. And you'll see that I'm starting to do something that is going to be continued, like I'm adding more layers in. So my repository, the meeting repository, looks like this. So first of all, I'm creating like an entity where I can inject stuff from the controller. I don't need to pass it around. I inject it at the right place. So the meeting repository will hold the Spring repositories it needs. And it has interfaces like add meeting and update meeting, which contain the saving and stuff like that. So if you look at the entity right now, the meeting, first of all, it doesn't have any notion of repositories passed in or not. So it becomes a bit smaller, it just has the meeting repository injected to it or passed to it. And basically Kafka's still here, it hasn't gone anywhere. I'm creating the repository inside here, it's not injected. And on schedule, I'm calling add meeting, and in invite participant, I'm calling update meeting, which makes more sense. It's not just save. I'm speaking the language of the domain, and then it will do that because it gets injected with the right thing. Okay, makes sense. Let's continue. So we talked about a repository and we talked about ports and adapters. An adapter basically is something that changes interface. You can see one in there. You can see a few in this picture. Basically, an adapter is something that a software design pattern that allows the interface of an existing class to be used as another interface. It's true, but it can do a lot more than that. If you think about load balancing, is you talk to a gateway in some manner, sending an API, and then it decides to route it in different ways. So it has some logic inside it. What else? You can change, modify interfaces like I did with a repository. My repository, my meeting repository holds Spring repositories and do something with it just by changing the interface, but changing the point of injection as well. So our life is full with adapters, and we did them for the repository. The next one will be for my Kafka sender. So let's go to the code. Right until now, we have the same Kafka code here. So initializing things here and sending the information here. So why does an entity needs to know about Kafka thing? It doesn't. So let's move this around. How can we do that? Well, another package called adapters. I'll create an interface called invite sender, just an interface. And then I'm going to define something called a local Kafka invite sender, which implements it. And this would be like running locally. Again, for this example, I can obviously inject it from Spring, but I can do different things that implement the invite sender, which basically is this. I just moved the code here, and I can implement different things to send the invite through email or whatever. And now my meeting entity becomes even shorter. It doesn't need to know anything about Kafka. So it just creates the local Kafka invite sender. We'll take care of that in a minute because it's very coupled to our Kafka. But other than that, it works with the interface. So the meeting becomes a lot more cohesive. It's everything about it is meeting started, invitees. It doesn't talk to the implementations of persistent or setting message. Now, let's talk about the final point because this is kind of a problem, right? Because it's still coupled to implementation. We don't want that. So next pattern we're going to talk about is a factory. Now, if a repository is a separation between usage and persistence, factory does a different kind of separation. It separates, it encapsulates complex creation logic if it exists, or just abstracting the type of object for the sake of the client. Basically, it separates the creation of an object from the usage of it. One of the things that I'm going to use, by the way, is something that you know already, which is Singleton. But what is a Singleton? Singleton is a way of putting a single state in one place. But when we expose it to another thing through a factory, the client that gets this object doesn't know it was a singleton. It could be just created for us. It could be a singleton. It could come from a pool of objects. The client doesn't care. So a factory encapsulates the creation. And I'm going to give you a few examples of that, because the repositories as well, if you, this is one thing, the repository is created now. I need to do it from somewhere else. So another way to do this is by adding factories. So I have a calendar factory. This is a simple thing. I can inject a calendar with Spring or create a new one. Examples for this. The invite sender factory, it will create an invite sender either through injection or what I set to it. And the meeting repository factory is like a simple singleton. So when a meeting object, the meeting entity talks to them, it's becoming through these interfaces or through a new invite sender factory, which will get me the instance. It will now separate the creation from this, and in different scenarios, I can set what is returned. And this is very cool, because what I've created right now, I've kind of sealed the entities, the meeting, from everything else. The controller still looks like, where's my controller? Needs some kind of injection. The calendar factory, it doesn't get a calendar or a repository in it. It just does this. The calendar factory now means that the calendar can be gotten from different ways. Could be from a repository or somewhere else. The meeting repository here that I'm doing here, it's getting passed to the meeting repository factory that can be pulled in from the meeting itself. So I've created a system that everything gets injected or set up at the borders, and the domain is pure. Doesn't have any dependency of how things are working, both from the API side and both from the other side, like the service operation, the repositories, or the messaging. I got something else. So you can see that this is pretty much organized. And what I do is pull things out to different layers, which makes sense. Let's look what I got. So I still have those tests that are still passing the data in the end-to-end, but I can do something else now. First of all, the unit tests. So I've got the meeting validator. Remember the anti-corruption layer? So meeting validator, I can test it completely as a unit test. Doesn't require Spring, doesn't require anything. It just does this thing by itself. Runs very quickly as a unit test. The other thing, which is more important now, I can test the meeting object as a unit test, because now I can mock the different adapters that it talks to. For example, the repository. So I can check, for example, the meeting is created, its status is created. When the meeting is scheduled, it's scheduled and saved. So it's checking that the status is scheduled. And I'm checking that it talks to the repository calls add meeting, because this is the interface that it talks to. I'm not even mocking the the database, just mocking the adapter. And I'm checking that when the meeting is scheduled and then it sends the invites, I'm calling the scheduling event, and I'm checking that a message was sent, but I'm checking with Mockito in these lines, making sure that an invite gets sent correctly with the right email. So my entities can now be checked without any containers. And this is very cool because the rules of my application or the complexity of my application, it's in there. It's in the entities, it's in the behavior. This is what I actually want to test. Everything else is integration, which we also would like to check, but this is the more important part. I also got something else. So an integration test basically is something that we can't really tell where integration starts and ends because like it's very vague. We can define whatever we want. So before that, the integration test that we had was something like an end-to-end, right? We called the APIs and check that the data got there correctly. But now that we have different adapters, we can do different paths of that. So what you see here is the test that checked the ones that we have as part of the end-to-end, but with the mocked messaging. So instead of just doing everything together, I can concentrate on the real data with a repository and check that the database is updated without focusing or checking on sending things through Kafka. And same thing here, that the invalid meeting data database is not updated. And then I can separate a mock database like here with real Kafka. So I raise up a listener and everything in terms of data gets mocked. You see the mock bin here. And I don't care about what's happening. So I don't do everything together. So what happens then? I have all kinds of tests. What do we have? So first of all, let's look at the results. Code organized better. We like that. Everybody likes that. The other thing, separation. We separated the domain from all the other parts, the persistence, Kafka, stuff like that. We got flexibility. If the domain objects are not coupled to the implementation, we can replace different stuff. And we also already seen one context when that was important, which is testability. I could mock stuff. And I can mock stuff in different ways and do all kinds of paths or integrations to see what's working. The final thing I got is what we call test overlap or test redundancy. Now, I've got the same path of the API, but I've got different tests covering. The end-to-end covers like end-to-end, but we also have unit test, which is smaller, different, the API to the database or the API to the messaging, and with other parts more. Why is that important? It's important because if we had to adjust the end-to-end and everything's working, cool. When something's failing, we need to understand what. And as you probably know, apart from having a fragile test, which we don't like, even when it's not fragile, it's failing for a reason, we need to dig deep to see where things have happened. If we have more tests about and checking the different paths and they overlap, that's okay in terms of coverage. We get more data information. We get more information about where things are working and where not. So obviously, if something is wrong in the unit level, that's cool. But if something is wrong with the Kafka thing, so the integration with Kafka will obviously fail, but the integration with just the database without Kafka will pass, and it will tell us, well, you know what? The database stuff is working. Focus on what's failing. So we gather more information from overlapping tests. That's cool. So to summarize, what we did is take something kind of messy and working, because we had some tests to prove it. We pull things around according to different patterns, repositories, factories, adapters, move them around and put them in the right place, injected them in the right place so we can modify them, and every piece of code now exists in its own space. We got a flexibility for that, and microservices are already layered. REST is already layered. It's supposed to do that. But once we start moving around to the different layers and we get a much clearer understanding of how the domain works, we can test it correctly. We know that if we need to modify the code, we need to find where to put it, not just dump it together with everything else, and make it easier for ourselves to modify, make changes, and to tests, because now we can test the things that we want to concentrate on in what way. And that's basically what I wanted to show you today. So thank you for coming. That's basically it. Want to remind you, testables things, microservice things, I can help you with that. If you need information, ping me. If you have questions, put them in the Q&A box. Otherwise, thanks for coming. Hey everyone, if you enjoyed this video, be sure to like, share and subscribe for more. Thanks for the support, and remember, live long and test.